Hello and welcome to episode 2 of Science on a Shoestring with Mr. S. Today we're going to be making a coin or a penny magically transform. It's not magic, it's actually science. So for this investigation, you are going to need a penny coin. Could try it with a 2p coin. You're going to need a small container, and you're going to need some cola as well. It doesn't particularly matter what brand it is. Maybe that could be a further investigation later on once you've tried it. There's something in it that's going to make this happen. So where does this fit in? Well, it fits in with chemistry. Chemistry is all about changes, and this is an example of what we call a chemical change. And normally what we say is a chemical change can't be reversed, it's an irreversible change, but there are actually some exceptions to that general rule. So we think about reversible changes, for example, salt in water. And if I were to put some rice in water, for example, I'd be able to get those things out. So they're reversible. Irreversible changes mean there's a change in the chemistry, somehow something has changed and a new substance is being created, and in most cases they can't be reversed. So examples would be things like bread in the toaster when it goes dark, for example. Another example would be vinegar and bicarbonate of soda, and it froths up and starts to spill out of whatever container it's in, and you've created a new substance in there. So for this investigation, firstly, you just need to take your penny. It looks dirty. It's not so much that it's dirty, it's that the penny is made of a certain metal. And that metal is called copper. And copper's used in many different real life situations. For example, the pipes in your house are made of copper. Very good at conducting heat, for example. And inside wires as well, copper's used. It's very good at conducting electricity as well. So take our copper penny. That's what we say. I've got some coppers here. That's why we say that. Slightly different in meaning to copper, like the police, for example. But maybe there's a link there. Maybe you could look that up. Take it, put it into the container. We only need a shallow container because you don't need an awful lot of cola to do this. I say cola because, like I said earlier, it could be any brand. Coke, Pepsi, own brand, supermarket, whatever it might be. We just need to have enough cola to actually cover the penny. So I'm only going to put a small amount in. Firstly, we don't need that much. Secondly, I don't like to waste things. So we just need enough to actually cover the penny. That's about enough. The rest I can enjoy. Make sure I've got a diet one, not too much sugar in my diet. Now the last thing that you actually need is a bit of patience, because nothing's going to happen straight away. So we'll give it some time, preferably overnight. But in the very least, you're going to need 12 hours for this. So, with the magic of video editing, and there we have it, just like magic, we've passed time. And also my sleeves have changed, because it's a new day. So what's actually happened then? Let's investigate, let's see. We put the penny into some cola. I'm going to retrieve it from the cola. Okay, something's changed, but because the cola's brown, it might be difficult to see, so I've just got a little bit of water just to rinse it off in. And let's see. There we have it. The coin seems to be clean. Something's changed about it. There's been a change. If I just flip it over onto the side, that was against the bottom of the container, you can clearly see that is the original colour of the coin. Flip it back over. That's the side that we'd say it's been exposed. to the cola more so than the other side. You can see a tiny bit around the edge. But what's actually happened here is that the coin appears to be a shiny and almost like a new penny. Something like that. This is a later produced coin. This one is from 1980. So this coin's been around for 40 years. This one, a newer coin, is from 2017. So you can see it's a lot shinier. So what's the difference then? And why did this one come out clean after we put it into the cola? So here's the science. Over time, this coin originally would have looked something like that back in 1980. But of course, it's been handled, people have touched it, but not so much that. More than anything, the metal that it's made from, if you can remember from earlier in the video, was copper. The copper's been exposed to oxygen, which is in the air that we breathe. Not all of the air that we breathe is oxygen, of course. That's a common misconception. Most of the air that you breathe in is nitrogen. It's the most abundant gas in our atmosphere. But there is oxygen in there, and that's the stuff that keeps you alive, so you definitely need oxygen. But over time, the copper's exposed to oxygen. And when you put copper with oxygen, you get something called copper oxide. And that tarnishes, that's the proper word, tarnishes, or makes it dull, makes the metal dull over time. It doesn't happen overnight. It takes years and years for that process to actually happen. So we talked earlier in the video about changes, reversible, irreversible. And I said that this was perhaps an example of an irreversible change that could be reversed. It's a little bit more complex than that. Over time, like I said, copper plus oxygen equals copper oxide, which gives it that dull colour. What we're actually doing here, when we put the coin in the cola, it's not just the fact that it's cola that actually causes this change to happen so that it looks shiny and almost like a brand new coin. In your cola, there are acids, okay? So when you drink cola, there's a tang to it, okay? And that'll be the acids actually affecting your taste buds. We can see here, I don't know whether you can see in the video, but just zoom in maybe. This one, this is the one. You can just about make it out. Anyway, phosphoric acid. Phosphoric acid, when it hits the copper oxide, it actually takes away the copper oxide. But here's the clever part about it. It's not that it completely reverses it and gets it back to the original state that it was before, because this chemical change has happened. It looks like it's been reversed, but what's actually happened is a very thin layer has been taken off the coin itself. So the copper oxide layer has been taken off the coin, and underneath that layer is a shiny new layer. So if you think about it like a block of cheese, maybe, you can slice a block of cheese, you can take a slice off. Eventually, you're not going to have any more cheese left, and you'll have to go to the shop and buy a new block. If you were to keep on exposing the coin to the acid enough times, what do you think might actually happen? Would you still have a coin? Would it be a lot thinner than it was when you first started? Here's a thought. How many times would it actually take exposing it to phosphoric acid to actually reduce the coin by even half of its original width? It might take a long time. From my eyesight, this isn't scientific because it's only my personal judgment. From my eyesight, when I take one coin, the coin that we expose to the acid, and place it alongside another coin, it looks like the exact same width. So I think that process would take many, many, many times to actually do that. But there you go. You can clean, but we've learned we're not so much cleaning the coin, but actually stripping a layer of copper oxide from it and make it appear nice and shiny and new. What else could we do with this? For this investigation, I used Diet Pepsi because I knew it had phosphoric acid in. Maybe another type of cola might work differently. You'd have to have a couple of different containers. You'd have to label them up. But maybe you could see which one gets the coin, let's use the word cleaner or shinier. Maybe we could try a different substance. Would orange juice work? Because I know that oranges contain acid. Would any other substance work? But of course, if you do use another substance, you always check with an adult to make sure that it's actually safe to handle. Many substances that we use in the kitchen are unsafe for us to handle. They can actually cause damage to our skin. So you never mess about with irritants, never mess about with things in the cleaning cupboard. Those things have a specific job to do on surfaces, not your skin. That's why we wear gloves when we do certain jobs. We see certain buildings. One that springs to my mind, I saw it many years ago, it's the Statue of Liberty. It's a large green structure. Well, guess what? It's not actually green. It looks green to our eyes. Originally, and because of the metal that the Statue of Liberty, a gift from France to the United States to celebrate 100 years in 1876, after 1776, when the Declaration of Independence was first signed. It was a gift made of copper from France to the United States. So the original colour of the Statue of Liberty was a copper colour. In the images that we have, at the time, in the late 1800s, certainly in the 1870s, it would have only been possible at best to get black and white photography, so it's really difficult to actually make out the original colour. But the statue that we see now is green. Well, why is it green? Well, over time, as the copper is exposed to the air, which contains a large amount of nitrogen, oxygen, and other gases, with the moisture in the air, what happens is copper, or certainly the top layer of the copper, it starts to change. It changes, becomes this green colour over time. And there are chemical reasons for that, which got me to thinking, if you could give the Statue of Liberty a bath in cola, I wonder if you'd be able to get it back to its original colour. But then that raises the other question brought up earlier in the video. If you did do that, you're actually stripping a layer of copper oxide from the statue itself. And you may, over time, if you were to repeat doing this, you may take away the actual pattern and design of the statue itself, and you'd be destroying history or a historical artifact. I don't think we want to do that, would we? If you want another actual real-life example of this, without having to go all the way to New York City, if you're ever in town, I know we can't go out much at the moment, but when you can again, and this isn't too far away from our school, when you're in town, look at the statues outside St. George's Hall. They are green in colour. Nobody painted them green. They were originally and are made from copper, which over time has turned into this green colour. Have you ever seen a penny that's turned green? I've had a couple like that. I wonder what's actually happened to them. Most of them just go dark. Like that. So, I hope you enjoyed the investigation, and maybe you could take it further. Different types of cola, different amounts of cola. What happens if you were to add another substance in, perhaps? Maybe you could try salt. Maybe you could try a mix of different colas. Maybe you could leave them for longer and time them. Maybe you could leave some things for a shorter amount of time. Just make sure you don't leave too much of a mess. Just make sure you don't leave too much of a mess. I have a work desk here where I can spill things. Obviously, you don't want to be spilling things in your parents' kitchen, or definitely not in the living room on the sofa or anything like that, especially if you're working with different types of liquids. They can stain. So don't mess about, and always have adult supervision for these investigations. Check it's okay with your parents first before you go doing anything. And with this in mind, these chemical changes that are happening, I got to thinking about another type of reaction. That's when one substance is exposed to another substance and something happens. And I've got an idea for my next video. So until then, stay safe. Goodbye.